Okay, gonna redo this. So we had a lesson today on how to find surface area and lateral area of solids. It didn't get recorded correctly, so this is not really a live class. I'm just going to record all the notes over again so that if you had missed class, you can watch this and get everything that we had gone over. Before we do so, I want to go over a couple of important items. The first one is if we go to the next slide here, just like every other class that we've had this week, there are some things that will be on the test, some things that won't be on the test. Today, we are focusing on lateral area and surface area. On Monday, we are going to be doing composite figures. I will include some volume in there as well. All that stuff will be on the next test. Then come Wednesday and Friday of next week, those two topics will not be on the next test, and that's density and scale factor stuff. But for today's lesson, since I've already done it once, I know how far I got with a live class, and I did not get through all of the notes for today. So anything that I don't get through today, I will continue on Monday in our second set of notes for this. I will also update these notes online so that they'll all be in one place, but there will be a second video posted to YouTube after the class session on Monday. Now, for all of our formulas, we're actually covering the biggest portion of our formula reference sheet that I had given you. So it is important that as we go through the notes that you have this reference sheet. If you don't have this reference sheet, then it's important that you print it out, because when it comes time to do our next test, which you saw from the calendar is on the 15th of May, you will really need to have this reference sheet with you. Probably next week. I haven't put on the calendar yet, but I think sometime around Wednesday of next week, I might throw a quiz in as well. So again, just be ready for that. So again, formulas that we're using, we're going to use base area, lateral area, and surface area formulas all in the section. We have done some stuff with base area already in order to do volume. But just remember, the base area will change depending on whatever shape the base is. For a cylinder and a cone, it always stays a circle, so that's the same no matter what. But for our prisms and our pyramids, again, whatever the base shape is will determine which formula we use as the base. Now, I also had a couple questions asked during the live session that I think I should go ahead and answer. First one is, the next test will be done on School City, just like the last one was. There will be a chance for a retake after the first window is over as well. I'll have it open same way that I did the last one. It'll start open the Thursday before, and it'll continue to the Sunday, and then afterwards I'll open up a different version of a retake. But again, I've seen all the questions on the tests, went through them myself. I would say that it is about as easy of a test that they can make for this section. It is, if you have this reference sheet already printed off and you're able to use it and understand it, then you should be good. There is a couple other formulas that you do need that we covered in that first section that were not on this reference sheet. I'll make sure I repost those. But again, I have already posted those on EDSB as well. All right, whoops. First slide. So the first slide was understanding the nets. I'm going to try and do this a little bit faster, so slightly different order than I had done it in class notes, but I'll make sure I cover all the same material so that I'm not missing anything. But for each one of these figures, there is a different net that you can have for each one of these figures. So I want to make sure first you understand what these nets look like. So before I even do anything on here, you have those four nets. I'm going to go ahead and cut over to just my video for a second and show these nets out loud, or show these nets in person so that we can see what they look like. So let me cancel the screen share for just a second. All right, so now it's just me. So there's a couple different shapes that we saw. We have our rectangular prism. We have our cylinder. Ooh, that's some horrible light. Hold on, let me see if I can do something about that. That's a little bit better. All right, so again, we have our rectangular prism. We have our cylinder. We have our cone. We have our square pyramid. And those are the shapes that we had seen on that image. So the first one Again, we got to remember what a net is. A net is what this three-dimensional solid looks like as a two-dimensional shape. So if we were to unfold it, again, this would be the net of that rectangular prism. So it's made up of just rectangles as the sides, which are the lateral faces. And then the two that are congruent on the top and bottom, those are our two bases. And again, we can have different types of prisms. So whatever the base is, that's how we're naming our shape. So this is a rectangular prism that we had here. The next one is our cylinder. And our cylinder is made up of circles for the bases. So if we unroll this, again, we also have one very large rectangle and then two circles that make up the bases. But again, that will fold up into our solid of a cylinder. Now, the next one, the cone, this is the one that people usually have a hard time picturing. And the cone is made up of part of a circle and a circle. The part of the circle that we have here is what we call a sector. Again, a sector is part of a circle. It can look anything like a slice of pizza to a semicircle, which this one's almost a semicircle, not exactly half of a circle, but it's almost a semicircle. And then you could even have something that's larger, like a pizza with a slice taken out. So it all depends on how big and what the dimensions of the cones are. And then finally, the last one that I had shown on there was the pyramid. And the pyramid is made up of triangles for all the sides and one other piece. So on here, we have 4 triangles and then a base, which is a square. But again, it is good to know that in these shapes, no matter what the base is, the sides for a pyramid are always triangles. The sides for a rectangular prism or any other prism are always rectangles. So we're going to draw these out now. So I showed you a quick sample of those. And since this is a video, you can go back and watch it if you want to see those shapes again. But I'm going to draw the nets now on the page that we had. So let's go back to screen share again. And we're on this slide here. So now that you have these 4 shapes and you've seen them, hopefully we can get a better idea of what they actually look like. So the first one, our rectangular prism, was made up of one large rectangle. And I'm going to separate this into 4 rectangular pieces that were all the different parts of our lateral area. So again, each one of these rectangles represents one of the 4 sides of that rectangular prism. And then on top, there was a square. And bottom, there was a square. Now, for our cylinder, we had one large rectangle again. One large rectangle. And then we had a circle on both the top and the bottom. For our cone, it was made up of a sector. Again, depending on the dimensions, it changes what the sector might look like. But that's our general net for our cone. And then our pyramid, we had one side was the base. So I'm going to draw a square down here. And then I'm going to draw a triangle. And all these triangles were congruent since this was a square. And it's not going to look perfect here by any means. I actually think this is much better than my earlier drawing was. But looks something like that. Now, talking about the formulas, because although you have your formula sheet, I do think it's important you understand where the formulas come from. Now, there's more than one way that you can do lateral area and surface area for these shapes. In fact, all these individual shapes that we just drew out as 2-dimensional shapes, we could find the area of those and add them together in order to get the lateral area or the surface area of a figure. In the first one, No, our prism, there is a formula that works all the time for lateral area. And that formula is lateral area equals the perimeter of the base times the height. And the reason this works is because the lateral area, when looked at together, is always one really big rectangle. So we take all the little rectangles, put them together, get one really big rectangle. In this shape, our height is here, right? This is the height of the prism, capital H. The capital P is the perimeter of the base. So when we unfold this, the length that we're talking about, that's our perimeter, is actually this length here. That's the perimeter. And this would be the height of the solid. Well, in a rectangle, the formula for area is base times height. Well, our base is the length of the perimeter. The height is the height of the solid. So that's why it works to find the lateral area of a prism. So again, perimeter of the base times the height. Then we also have surface area. For surface area, we have a little bit more to the equation, and you can write the equation many different ways. If you look at the reference sheet that I had posted, I posted this a few different ways. For this problem, I'm just going to go ahead and write it like this right now, because this applies to any prism that we have. So we have two bases, so 2 times the base area, because again, in this shape, we had 2 squares. So we plug in the formula for area of a square, which could be just S squared. Or we could do a rectangle, base times height. Or if we had a triangle as a base, we'd replace the base area with 1/2 base times height, and so on. Whatever shape the base is goes in for big B. And then perimeter times height. You could also just write lateral area here, but again, it will always be using the perimeter of the base times the height. So I'll explain a little bit more on one of the future slides when to use something like this, or when to get more specific, or when to get even less specific with writing your formulas. But again, if you have your reference sheet, that'll help you in determining how you want to write your formula for each problem. So now, this one is our cylinder. For our cylinder, it's very similar to our prism. In fact, they're related. The only difference is we don't have a perimeter when it comes to the base of our cylinder, because our cylinder has a circle for the base. So a circle doesn't have a perimeter. It has what we call a circumference. But circumference and perimeter have the same definition except for one thing. A perimeter is the distance around a polygon. A circumference is the distance around a circle. So instead of P, we're going to use a C. So circumference times height. And same way that I looked at the big rectangle here, when you unroll this, this length has to wrap around this circle. So this is actually the circumference of the circle. So that bottom piece that's touching these circles is the circumference of that circle. The height is still that other piece. So again, circumference times height, same formula essentially. For the surface area, again, same formula. There's still 2 bases, but instead of saying perimeter times height, we can actually plug that in. Now, we can plug a lot of stuff in here. In fact, since we have a circle for the base, we can go ahead and plug in the equation for the area of a circle. So if we want to be more specific with this one, we can, because every single time we have the same formula for the base. So we're going to say 2 times the area of a circle, which is pi r squared, plus the lateral area, which can be defined as CH, which in my earlier notes I just wrote CH, or if you want to replace CH with the actual equation for circumference, you could do that too. Circumference formula is 2 pi r, and then we're multiplying by the height. So again, that would be our equation for surface area. For a cone, we have lateral area. Now this one's a little bit harder to understand, but you can use the equation of a circle and the equation of a sector in order to come up with this equation. There's a little bit of simplifying involved to get down to the final equation, but there's a really good simplified format here. The one thing that you have to keep in mind is we're going to use something called the slant height. Slant height is not the same as the height. The height would be coming straight down from the top, down through the bottom to the middle of the circle, so that we had the perpendicular distance from the base to the vertex. That would be our height. We're not doing the height, we're doing this piece over here called the slant height, and we're using an L for that. So L represents our slant height. And it can be a cursive L, an italicized L, but you just need to know that that piece is called our slant height. So this piece on the edge that's running along the side of the cone, that is our slant height. Now, for our equation, the lateral area can be found by doing pi r L. So pi times the radius times the slant height. So then our surface area, you could say the base area plus there's the lateral area. So very simple, B plus LA. Or again, since we have the base area as a circle, we can go ahead and plug in some of these values. So area of a circle is pi r squared. We only have one base, so we only do pi r squared. We don't have a 2 out in front like we did in the last equation. And then add to that the equation for the lateral area. So pi r L. All right, and finally, oh, before I go to the last one, so I had drawn this sector. Now just know, a sector can be a part of a circle. It could be, like I said, a slice of pizza looking piece. It could be a semicircle. It could be something much greater, like a pizza with a slice taken off. But again, just so you remember what a sector is, because I had some questions about this when I did this the first time. I'm gonna draw a circle down here. I'm gonna draw a pizza slice here. That can be a sector. So again, either the part I shaded in can be called a sector, or even the part that's not shaded in could also be called a sector. So the part here looks more like what I have shaded in. Or I could have a different type of cone that would have a lateral area that looks more like the other half of it. Again, it could look either way. So now, lateral area for a pyramid. For a pyramid, lateral area is found by doing 1/2 the perimeter of the base times the height. Pretty much the same idea as what we did way over here with our prism, except the sides of the prism were all rectangles. The sides of the pyramid are all triangles. Well, what's the formula for area of a triangle? It's 1/2 base times height. Again, just like we replaced the base with the perimeter of the base in a prism, we did the same thing in this equation for a pyramid's lateral area. So instead of having 1/2 BH, this is 1/2 perimeter of the base times height of, ooh, I made a typo here. There is a typo, and I'll have to fix this in my class notes because I made the same typo earlier. I put 1/2 PH, that is incorrect. It's 1/2 PL. And I didn't get to, I don't think I got to an example with the pyramid, so I'll have to go back and correct that in our notes for Monday, but I did just catch that mistake just now. It should be 1/2 PL because we're talking about the slant height on this pyramid. So if I draw that in, the slant height here is what we need to use when we're doing the lateral surface area, not the height. So I'll have to go back and check to see if I had made any other mistakes with that earlier on. I think I did. So I'll have to fix that and talk about that during class because that was a mistake. So again, other thing to note here, for this shape, the height and the slant height, if you connect the two, it will always make a right triangle. So you might have to do things like Pythagorean theorem in order to solve for a missing piece. Keep that in mind when we do some problems later on. All right, the other thing that we need is surface area formula. So again, surface area is going to be base area. Again, it can be replaced by any base that you have, whether it's a square, a rectangle, a triangle, a regular polygon, anything can be plugged in there. Plus 1/2 perimeter times, I almost did it again, slant height. So I'll have to fix that on the notes that I had posted as well, because I did that mistake several times. And let me see if there's a problem that we had done. We did get to one pyramid question, so I'll have to fix that. So, all right, that was the last one we did. And we're kind of in a rush when we got to the end, so I'll fix that on our other set of notes. But at least if you're watching this video, you do have the right thing. All right, let's keep going. The next slide that we have. So now there are two prisms, and I have extra examples in here. This one I'm going to do both of these examples. I'm not going to do the base area, lateral area, and surface area of both these figures, but I do have other examples in here that I'm going to do on Monday, because we're going to focus mostly on composite figures on Monday. So some of these are made up of composite figures. There's also some other ones that I just want to point out that I'm not actually going to do, because again, I want you to understand what will be on the test and what won't be on the next test. So for both of these are both considered triangular prisms. So we have on top, we have a triangle on top here and on bottom. So again, this is a triangular prism because it is a triangle for the base and all the other sides are rectangles. This one too, we have two triangles that are in parallel planes and are congruent. So the triangle that's on the front and the back, they are the bases. So let me highlight one of them here for us. Again, those triangles are the bases. It doesn't matter that it's tipped on its side. Base does not mean bottom. Base means it's the two faces that are parallel and congruent. So they're in parallel planes and they're congruent to one another. The rectangles in that second image are not parallel to each other. They cannot be the bases. All right, so in order to do either one of these shapes, no matter which one we choose, again, base area is something that we're gonna have to find. We're gonna have to find lateral area, and we're gonna have to do surface area. Now, you can tackle these a couple different ways. Base area, it's gonna be the same no matter what. We're gonna do the formula for area of a triangle on this one. So 1/2 base times height. For the lateral area, again, lateral area will be found by doing the perimeter of the base times the height of the solid. The surface area, that'll be done by taking the area of the base times 2, 2 times area of the base, plus the lateral area. Now, you could also get more specific. So this is a very general formula that will work for any prism. But again, in these two, we have something a little bit more specific. We could plug in these other formulas that we already had. So 2 times the area of the base is 1/2 base times height. And for the lateral area, it was the perimeter times the height. You could even simplify this. 2 times 1/2 would cancel out. So for these two, if I was just finding surface area, I could plug into that formula. Excuse me. All right. On the first one, so I want to find all 3 parts. I want to go ahead and find the base area, the lateral area, and the surface area. Okay, so in that first one, we have, let me find my cursor here. There it is. All right. We have base area. We're going to do the 1/2 base times height. Plug in. Well, which one's going to be the little b? This 9 I could use as b. The 12 I could use as the height. And I don't need to use the 15 for anything right now. This 5 over here, well, that's the height of the solid. So this will be my b, that will be my h, plug them in. And you could reverse the order. It doesn't matter which one you plug in where. So the 9 and the 12, again, could have been 12 times 9. Either way works. We're going to multiply this thing out. 1/2, 9 times 12. Well, I would do 1/2 of the 12 first. Gives me 6. 6 times 9 gives me 54. Now, once I have that 54, we're going to take that and we're going to use that in our surface area formula. Now, I didn't have any units on here, so I'm not putting units. If I had units, it'd be in squared units. For lateral area, all right, we now have perimeter times height. Well, what's the perimeter here? Well, I have 9, 12, and 15. So for a perimeter, I'd have to add those up. 9 plus 12 plus 15. And if I add all those up, let's see, you have 12 plus 15, that's 27. 27 plus 9 is 36. So our perimeter, I lost my cursor again, is 36. So when I plug this into the formula, I have 36 times my height, which is 5, because again, the height is the distance, the perpendicular distance between the two bases. 36 times 5 is going to give us a total of 180. So that's my second answer. Now, once I have those two pieces, I can do surface area a couple of different ways. I could either go and use this final formula that I had over here, but that'd be a lot of extra work because I've already found base area. I've already found lateral area. I might as well use the 2b times LA because I've already done the work to find the base area. I've already done the work to find the lateral area. So there's no need to do all the work all over again. I'm just going to plug in those two parts. So 2 times the 54 plus the 180. Again, I just plug those two pieces into that formula. So 2 times 54, that's going to give us 108. And 108 plus 180 gives us a total of 288. And that's my answer. Now, for the other shape, let's say, actually, before I do that, I had a question during the live session about how exactly I got my lateral area. What values in that image actually represent the lateral area. So let me draw real quick a representation of this shape as a net. So all right, so I have my 2 right triangles on top and bottom. These are my 3 sides. The lateral area, again, the definition of lateral area is the sides or the faces that are not the bases is an easy way to describe it. So you have all of those shapes, all those 2-dimensional shapes make up faces for our 3-dimensional solid, but the lateral area are all the faces that are not the bases. So all the rectangles. So in here, let's go ahead and shade this rectangle, and this rectangle, all make up the lateral area. That's what we're talking about when we're doing lateral area. And again, if you really wanted to, you could find the lateral area by doing the area of each one of those rectangles separately. So like we had a 5x9 rectangle, a 5x12 rectangle, and a 5x15 rectangle. Add those up separately and then add them together. That would give you the same lateral area. Excuse me. So we have another image over here. And instead of finding all 3 of these things on this image, I'm just going to do surface area. But in order to do surface area and only surface area, that means that I don't want to find the lateral area by itself. I don't want to find base area by itself. So this is where I'd want to use that final formula that I had simplified earlier to do my surface area. So on this one, I'm going to do surface area equals BH plus PH, because that's a simplified form for this figure. Now, I need values to plug into each of those. I have, and it's very important you plug in the right pieces to the right spots. So remember, the base is not the bottom. The base is this triangle that I've already highlighted in red. So let's say that this 12 is going to be my base for my base, and the 5 is going to be the height of the base. It's not the height of the solid, and that's one of the things that people get confused the most. Yes, that looks like the height, and it is a height. It's a height for the base, this rectangle that is my base. The height of the solid is the 3 that's back here, because that's the perpendicular distance between the 2 bases, which are the right triangles. So again, this is the height of the prism. So you have to make sure you plug them into the correct places. Also, the perimeter that I'm finding is going to be the perimeter around the base. So around this around the triangle that I highlighted in red. Well, we're missing one of the sides. Now, you could do that a couple different ways. If you remember your triples, this is one of those places the triples come in handy. This is what we call a 5, 12, 13 right triangle. So the missing side is 13. And if you remember your triples, and if you memorize them like I asked you to a long time ago, you don't have to do any extra work there. You just know it's 13, you move on, you keep going with the problem. If you don't know that, that's where Pythagorean theorem comes back in, and you have to plug into Pythagorean theorem to find it. And you may have to do something like this on the next test. So c squared equals a squared plus b squared. We know the two sides were 5 and 12. So again, just showing you how to plug into this one more time. Hold. Okay, sorry about that. That was my little daughter. Anyway, so in here we have, for the equation, if you're using Pythagorean theorem, the 13, the one that we're trying to find there, that was our longest side. So that's our C value. We didn't know that yet going in. So we plugged in the 5 for one of our legs. We plug in the 12 for another leg. And then we are going to square these and add them together. So 5 squared is 25. 12 squared is 144. Add them together and you get 169. Now, to get to C by itself, you have to square root that 169, which is 13. So again, that was a whole lot of extra work that we didn't need to do if you remember your triple of 5, 12, 13. And again, for the next test, I would have some of those triples written out so that you don't have to do Pythagorean theorem. Because most likely, if there's a Pythagorean theorem problem, it'll be with something that is a Pythagorean triple. So a 3, 4, 5, a 5, 12, 13, and other ones like that. So on here, let's keep going with this. Now that we know all of our values, just plug it into this formula. So we have base, the base is 12. The height is 5. The perimeter of the base, well, again, you had to add up all these pieces. So 5, 12, and 13 added together is going to give us a total of 30 for our perimeter. So let me just write that down here. So we got 30 for our perimeter. And then plugging that in, 30 times our height, which is 3. Again, the 3 is the height of the solid. That's the capital H. 12 times 5 is 60. 30 times 3 is 90. Add them together and we get a 150 for the surface area of that solid. So you don't have to find the lateral area and base area separately in order to do the surface area. Now, if you notice, again, this 90 over here, that is actually our lateral area. This 60, that's not our base area. That's our base area doubled right now. So again, you can also pull things out of this equation if you need them later on to go backwards. But again, you don't have to. This is, again, 2 different ways that you can tackle some of these problems. All right, let's look at the next slide. So I'm not doing anything with this slide today. I will do more with this on Monday. I'm not really going to look at this one at all. The first one on here, it's a right regular pentagonal prism. Yeah, that's a mouthful. But again, a regular pentagonal prism we can do using our formula, and I put the equation on our reference sheet, the 1/2 ASN for area of the base. Again, you may have to use the 1/2 ASN, but this problem I put on here as an example of something that you wouldn't have to do on the next test, because I am not going to have you do any type of trig on the next test. So this problem requires trig. A hexagon would require a special right triangle. That's something you could see. Probably still not going to do that. If I gave you a regular polygon as your base, I would end up giving you the parts that you need to plug in. So either into the formula 1/2 ASN or 1/2 AP. For this one, now, if I just want to find lateral area on this one, I don't have to do a whole lot because I have the height, I have the lengths of all the sides of the bases, you can find lateral area without doing anything else. The other image that's on here is a composite figure. Now, you might look at it and be like, oh no, why is that a composite figure? There's nothing there about that you'd have to look at as combined figures. You have a pentagon as your base. It's a prism, so you have a pentagonal prism, just like we had over here. This is not a regular pentagonal prism. This is still a pentagonal prism because the pentagon is the base. The front and the back would be the base is on this one. But the major difference here is we can't find the area of this shape that is our base without cutting it one of a few different ways. You could just go along this and have two trapezoids that were equal, or I prefer this route. Use that one. Again, you could do this a couple different ways. Now, if you cut it the way I cut it, you'd have to do some subtraction to get the height separately. That's fine. But again, we'll do that shape on Monday. All right, let's go on to the next slide. Okay, so now on this slide, we have the base area is going to be a circle. So this is actually a cylinder, and I have two shapes here. Again, the one on the left is a basic cylinder. The one on the right is a composite figure of two cylinders. Now, the composite figure we're not going to do today. We have the composite figure, I'm going to say, for Monday. All right, a little bit of background noise, but that's okay. Anyway, let's keep going. We got the cylinder that I had talked about. Again, not doing the composite figure over here, but if you think about what this composite figure is, it's a big cylinder minus a little cylinder. Now, I know the dimensions are way too big for this, but if you think of it as like a roll of toilet paper or a roll of paper towels, again, there's a cylinder with a cylinder inside of it removed. We'll take a look at that image on Monday. The other one is just a basic cylinder. So again, our formula for our cylinder, we have for base area, we're using the formula for a circle, pi r squared. For our lateral area will be found by doing the circumference times the height, which you could also plug in the formula for circumference because we have that formula from our previous chapters on circles, just 2 pi r. That's the formula for circumference. So then that times height is also good for lateral area. For our surface area, again, just like our other one, we can do 2 times our base area plus our lateral area. Or we can plug in these two equations that we had here. So we can do 2 times pi r squared plus, and then the lateral area, 2 pi r h. 2 pi r h. So on the first image here, we are going to do the base area. And I don't expect you to write out these formulas every time. That's why I gave you guys a formula sheet so that you have these and you don't have to write them out every single time. Again, once you know what they are, you can just start plugging into them. So base area, pi r squared. We have pi, the radius is given to us, it's 2. And this is our radius here. This 6 will be our height. So pi 2 squared. 2 squared is 4. Our answer is 4 pi. We can leave it in terms of pi. Again, if we wanted to change it into something that's not in terms of pi, then you'd be multiplying by 3.14. But again, for this, leave it in terms of pi. Now, this one has units included in it, so we can actually give some units here. Again, like I said on the previous one, if we have units, they're going to be in square units because we're dealing with area. We're not dealing with volume right now, so it's not going to be cubed anymore for these types of problems. It'll be squared. For the lateral area, again, we're going to do the second formula. Again, circumference times height, so plug into the circumference formula, 2 pi 2, because again, 2 is our radius, and then our height is 6. So 2 pi 2 times 6. Well, 2 times 2 is 4. 4 times 6 is 24. So we have 24 pi. Now, once you do that piece, all right, we are going to take this, and that is our answer. Or, again, multiply by 3.14. Again, add on the units. feet squared. But now that we have base area and we have lateral area, we can do surface area. And we don't have to go all the way to this final thing. We already have both of these parts worked out. So we're just plugging into the simple version of that formula. Surface area equals 2 times the base area. So 2 times the base area we found is 4 pi. The lateral area we found is 24 pi. So we have our surface area. 2 times 4 is 8. So we have 8 pi plus 24 pi gives us a total of 32 pi feet squared. That's my final surface area. So I have my base area, again, was 4 pi feet squared. My lateral area, 24 pi feet squared. And finally, my surface area, 32 pi feet squared. But again, it is the same idea of being a squared unit because we're talking about area, something that's two-dimensional. If we were to unwrap all of it, it's a two-dimensional figure once it's unwrapped in the shape of a net. So again, area versus volume. This is only two-dimensional, so it's in units squared. All right. Let's go to the last slide that I got to, and this is the one where I made a little mistake, actually kind of a big mistake, when I was doing this live during class. That I'm going to go back and make sure I correct on Monday, and I'll post something on Edsby about it today as well. So we have some dimensions given to us. I included this other figure, and even though I included this figure, I still made the mistake, and I included it for this reason. We have height, we have slant height. Again, when we're doing the lateral area and the surface area, we are not going to be using the height on this pyramid. That goes for cones and pyramids. When we do area related stuff, surface area, lateral area, we should not be using height. For surface area and lateral area, for a cone and a pyramid, you have to use the slant height. So that was my mistake during class. But again, like I said before, the height and the slant height, if you connect them together, it makes a right triangle. So now over here, we need a few different things. So right now, if we write out our equation, let's go ahead and write it out here. Base area equals, well, it's a square. So I could just do one side squared. Or if you want to call it a rectangle instead, base times height. But again, B and H in this case are going to be the same value, but they're missing. We're going to have to find that in just a minute. Also then for lateral area. Lateral area, our formula for lateral area is 1/2 PL. And then our surface area formula is going to be the base area once we find it, plus the lateral area. Or if you want to do the whole thing, we could write something like S squared plus 1/2 PL. Again, it just depends on how you want to do this problem. But I'm asking in the directions for base area, lateral area, and surface area, so I'm going to do it that way. For base area, we don't have any of the bases. However, we do have the height, we do have the slant height, so I can connect them. And when I connect them here, I make a right triangle. And since I have a right triangle, I can use Pythagorean theorem to solve for the missing side of a right triangle. Because I have 2 out of the 3 sides of the right triangle. Again, if I know my triples, we don't even have to use Pythagorean theorem. There is a triple that uses 30 and 34. Now, if you know that triple, I'd be surprised, but you may know the simpler version of it. We have 8, 15, 17, which when doubled gives us 16, 30, 34. If you don't know that, you're going to have to use Pythagorean theorem. So in this one, the 34 would be your c squared value. The 30 would be one of your legs. You'd have to find the other leg. All right. I'm not going to go through all that work. I'm not going to do Pythagorean theorem every single time, especially when we get to bigger numbers like this, because the whole reason you're supposed to know your triples is so that we don't have to do that every single time. So we have 34, we have 30. So the missing side here is 16. Now, if we know that 16, well, that's only halfway across the figure. So all the way across the figure would be 32. So this is going to be 32. That's going to be 32. So we have our 2 sides that are 32 inches. So now we can plug into the area of the base. So base area equals 32 squared. Again, you could also say it's 32 times 32, which gives us 1,024 inches squared. Then we have our lateral area. Lateral area equals 32, oh sorry, not 32, 1/2 perimeter times slant height. And again, this is where I made my mistake in my last class. I accidentally did height instead of slant height, so my answer is going to be slightly different than my earlier class. So we have 1/2. It's an easy mistake to make. So again, you got to be careful anytime you do anything with the lateral area or surface area. Make sure you're using slant height when it comes to our cone and our pyramid. So perimeter of the base. Well, the perimeter on this one is going to be all four sides are the same. So I could say perimeter. I'm going to do this off the side. I can do by doing 4 times 32. 4 times 32 is a total of 128. So 4 times 32 gave us 128. We plug in the perimeter, 128 times the slant height of 34. So now, do that on our calculator. We're going to have 1/2 times 128 times 34 gives us 2,176. Again, this is in inches squared. So that's our second part of our answer, 2,176 inches squared. All right, so for our final surface area, we're just taking the base area plus the lateral area. So base area is 2,176 plus the that was the lateral area, my bad. I reversed them. Let me write that in the same order so it doesn't confuse anybody. Let's reverse this. I don't want anybody to get confused here. So base area, let's do the 1,024 plus the lateral area, 2,176. Again, it doesn't matter what order you add them in, but for the purpose of notes, it's good to follow the same order as the equations I've been showing. So add that 1,024 and the 2,176, and you get a total of 3,200 or 3,200. And that is in inches squared. So again, that's our last part of this problem. That's our surface area. And I'll have to correct that on the notes online. But that's it for today. That's where I ended notes. There are a few other slides, so just to flip through them real fast. Still tomorrow, or not tomorrow, Monday to come, we're going to talk about cones. We're going to talk about some more composite figures. We're going to talk about hemispheres and spheres. But again, the majority of class, after I get through the one on the pyramid and the one on the hemisphere and sphere, sorry, the cone, the sphere and the hemisphere, we'll do the rest of it is all going to be composite figures. So there's several composite figures that were in these slides. There's this one, and that one, and one more. Oh, there it went, this one. So we'll take a look at those on Monday, and that'll be it. So the assignment for today, let me go to the end. This is the beginning of the first assignment. There are 2 assignments when it comes to this section that are due on Tuesday. On Tuesday, the first assignment comes from the Springboard pages, which I'm posting online here in a few minutes. Again, it's pages 12, 14, 15, and 17 with those numbers, 61 to 64, 71 to 74, and 86 to 88. Those are the only problems I want you doing on those 4 pages. But again, those are up, or they will be up on EDSB by the time this video is posted. Hopefully, you guys were able to follow that. Make sure you have the formula sheet printed out and handy anytime you're doing any of this work or any of the tests or the possible quiz next week. All right, have a good day.